Right, here's a short video on how to do more advanced vector diagrams. Okay, so it says here, a fisherman comes to help pull the boat. Each fisherman pulls with a force of 300 newtons and shown in diagram 2 here. Diagram 2 is drawn to scale, so that's good. So that means we can use the diagram. Add to diagram 2 to show the single force that has been the same, that has the same effect as the 300 Newton force. Okay, so what we've got to do is line our ruler up with one of the forces, and then we keep that orientation of the ruler and we move it to the tip of the other force arrow, trying to keep it the same. So basically we've got these two parallel, and we draw it as a dotted line there. We draw it a bit too far, or further than we need to, just so we can get them to cross over. And we repeat again. So we line our ruler up like so with our force, and then we keep that orientation of the ruler and we move it down till it reaches the tip of the other arrow, which is there. And we draw our, oh, that's not low enough. We draw our lines going across like that. So now what we've got is we've got that one parallel to that one that we've drawn, and that one roughly parallel to that one that we've drawn. And then just the same as before, we start at this point, and then we draw our resultant force from our dot that we drew to where those dashed lines meet. Okay, and that is our resultant force, just there. Okay, and now next stage is to work out what the scale is, because we haven't been given it, but we can work out the scale by doing this. So first of all, we write 300 newtons equals, because we know that that arrow is 300 newtons, and we work out how many centimeters 300 newtons equals. So it's from there to there. So we do that, it comes out as 3.1, 2, 3, 4 to the tip of the arrow. So 300 newtons equals 3.4 centimeters. Now we want it per 1 centimeter. So all we do is 300 divided by 3.4. That will give us it per centimeter. It's just a lot easier to work out. So we do 300 divided by 3.4 gives us 88.2. Okay, so we can say 88.2 newtons equals 1 centimeter. Then all we have to do is work out what our big long resultant force is in centimeters. So we know if we got that there, that's 6.1234 to the tip. So we know that it's 6.5 centimeters times by 88.2, because 1 is 88.2, so 88.2. And if we do that on the calculator, we've already got 88.2 on there, so we times it by 6.5. That gives us our answer, which is 573.5. Okay, so our resultant force is 573.5 newtons. And that will get you 4 marks. Right, this one is a particularly awkward one. In fact, I might go back just a second and just show you how to do the direction on this if it asked you. So you assume, if it doesn't say otherwise, north is directly up. So that is north, okay, directly up. And then all we do is follow from 0, because that's what north is, 0, all the way around until we reach our resultant force, which is there. So we're 0, we follow that round, and where our resultant force is, it crosses it at about 100, between 109 and 110. So I'd say about 109.5. So our direction would be 109.5 in this case. We don't need to do it with this question, but they might ask. Right, here is this one. And this is a particularly awkward question. So figure 3 shows a small aircraft being used to tow a glider. Notice not to scale. If it's not to scale, you need to draw your own diagram from scratch if it says not to scale. The tension force in the cable can be resolved into horizontal component and a vertical component. Okay. The tension in the cable is 2,000 newtons. The cable makes an angle of 20 degrees with a horizontal. Draw a vector diagram to determine the magnitude of the two components of the tension force in the cable. So this is what we have to do. We will draw that horizontal line first. So what we're going to do is draw a horizontal line there. I'm going to draw it as a dashed line, just like they've done on the plane. Okay, and we're going to mark that there. Okay, now we know that the cable's pulling in that direction. So what we're going to do is we're going to draw the arrow going in that direction. Okay, so we know it's going to be 20 degrees because that's what it says. Okay, so what we do is we draw our resultant force of 20 degrees. So from the horizontal it's 0 and 20 degrees is that one there. So we mark that here. We make just a mark so we know what 20 degrees is from the horizontal. So that's 20 degrees from the horizontal. So we've sorted our 20 degrees out. Now we need to work out how long our arrow needs to be. So we need to come up with a scale. Okay, so what I'm going to do is I'm going to say that 2,000 newtons, 500 goes into it 4 times. So I'm going to say 500 newtons equals 1 centimetre, just because we haven't got much room. If you wanted to do 500 newtons, so if you wanted to do 200 newtons equals 1 centimetre, you could do that on a separate piece of paper if you wanted to. Okay, but I'm going to do 500 newtons equals 1 centimetre. Now because 500 newtons goes into 2,000 4 times, I'm going to have to draw a line that is 4 centimetres long. So what I do is I get my ruler lined up. So 1 is on that point and 2 is on where we mark the 20 degree point. That way we know it's going to be 20 degrees. And then what we do is we mark 4 centimetres. So we won't go as far as that mark, we're just making sure that's there so we know it's 20 degrees. So we're starting at 8, so that's 1 centimetre to 7, 2 centimetres to 6, 3 centimetres to 5, and 4 centimetres to 4. Now remember, it's 4 centimetres because we've chosen the scale 500 newtons equals 1 centimetre. So that means 4 centimetres represent 2,000 newtons. And we know that angle there is 20 degrees because we measured it. And if we can double check that that's 20 degrees or in and around, which it is. Okay, you can see it's 20 degrees. Now, what we've got to do is draw our vertical and horizontal now. Okay, so first of all, we draw our construction line. So we've already got one there, and we draw another one going down like that. It doesn't matter if we draw them too far, and then we draw another one there. That one's parallel to that one, and then that one is parallel to that one, like so. And these are our construction lines. Now the lines coming from our dot can be turned into force arrows, because remember the forces always come from that dot point. So that's our vertical force, and this is our horizontal, which comes here. Then all we do is measure those and use our scale to work out what the force is. Now remember, you have to get that angle right. If you haven't got that angle right, these will be different lengths and you won't get it right. So let's do the horizontal and the vertical. So we know that the horizontal is this many centimetres, which is 3, keep moving it. So we've got 3.5, 3.6, 3.7. So I would say that's between 3.6 and 3.7. So we'll put that as 3.65. So 3.65 centimetres times by 500. Okay, and if we do that, 3.65 times by 500 gives us 1,825 newtons. So our horizontal is 1825 newtons, and then our vertical, we've got to measure that one there, and it is, that is 1, 1.1, 1.2, 1.3, 1.4. So we say 1.4 times by 500. Okay, so 1.4 times by 500 gives us 700. Okay, so we know our vertical is 700 newtons, and it's that simple. Okay, well, awkward but fairly simple. Hope that helps.